Hello everybody, I am so glad that you came back, and today we are going to be reviewing factoring techniques. And I think that most of these will be familiar to you, but there may be a few that you haven't seen before. That's kind of what happens in pre-calculus, especially in the first couple of chapters, is that you're going to see a lot of things that you've done before. However, we might throw in a few new things along the way as well. So this is going to be notes number 2, factoring. And what we're going to do is look at many different types of factoring and do an example of each type. So the first one is factoring out a greatest common factor, or GCF. So here's our example. We have 3 terms, and let's take a look and see what they all have in common. What could we factor out of all 3 terms? So go ahead and pause the video and write down the problem. You can even work on it if you want before you listen to me explain it. So I notice that all of the numbers are divisible by 7, so I'm going to factor out a 7. All of the x terms, or shall we say x factors, are divisible by x squared, so we can factor x squared out of all of them, and we can factor y squared out of all of them as well. So if we factor 7x squared y squared out of all 3 terms, what do we have left? In the first term we have 2x, then we have minus, and in the second term we have 4y, and then we have plus, and then for the third term we have 3. Okay, so this is factored now. What does it mean to be factored? To be factored means you now have a product. So we have the product of 7x squared y squared times 2x minus 4y plus 3. Okay, let's move on to the next one. By the way, looking for a greatest common factor is generally the first thing you want to try. So if you factor out a greatest common factor first, there still might be other things to do to factor later, but it usually makes it easier if you do that first. Now let's look at some trinomials. Okay, number 2 is 5z squared plus 4z minus 12. Now, not every trinomial is factorable, but when they are, what we typically do is kind of reverse the FOIL process. So remember, in the FOIL process, you multiply the firsts together to give you 5z squared. So what would we multiply to give us 5z squared? It would have to be most likely 5z and 1z. Okay, and then remember, in the FOIL process, we multiply the lasts together, and the last would need to multiply to give us negative 12. So there are actually quite a few combinations of ways to get negative 12. It could be negative 3 and positive 4, positive 3 and negative 4, negative 6 and positive 2, etc., etc. So the key is to find a combination, if possible, so that when we multiply the insides and outsides together, they will add up to 4z. Okay, so it's all right to go through a trial and error process for this. And I think that, in fact, I even paused my video so I could stop and think about it. And I think that I'm going to try 6 times 2 to give me 12. I'm going to make it positive 6 and negative. Oh, I think I'm going to switch those actually. I'm going to make it negative 6 and positive 2 to give me negative 12. Now let's look at what we get when we multiply the outsides together. That gives us 10z. And when we multiply the insides together, that gives us negative 6z. And notice that those add to 4z, and that's what we needed in the middle. So we have our factors, 5z minus 6 times z plus 2. Okay, let's take a look at another trinomial. 3x squared minus 15x plus 16. Okay, let's try the same process. To get 3x squared, it would have to be 3x times x. And then to get 16, we have a couple of choices. We could do 16 and 1, we could do 8 and 2, we could do 4 and 4. So what we're going to do is try all of those combinations until we find the one that gives us negative 15x on the inside. Now, I pressed pause and I went through the different combinations, and I didn't find one. And I found it's kind of time consuming to have to go through all the different possibilities and wonder if you make a mistake or not, then did you actually miss out on the one it was supposed to be? So here's a little extra tip. Remember the quadratic formula? And inside the quadratic formula we have something called the discriminant. And that would be the quantity b squared minus 4ac. That's the quantity that's under the square root sign in the quadratic formula. The reason it's called the discriminant is because it helps you to discriminate, which in this context is actually a good thing. It means it helps you to figure out which case you have. So when the discriminant is a perfect square, then you have something that's factorable. If it's not a perfect square, you don't have something that's factorable. So let's find the discriminant for number 3. So the b value would be negative 15, the a value would be 3, and the c value would be 16. So b squared minus 4ac is going to be negative 15 squared, so that's 225, minus 4 times 3 times 16. And that works out to be 33. And 33 is not a perfect square. And so this is not factorable. So if you keep that idea in mind, it might save you a little time on factoring problems in the future. Okay, let's move on to our next method. It's called a perfect square trinomial, or perfect trinomial square, or just trinomial square. Everybody calls it something slightly different. We're still looking at a trinomial. So we have 3 terms, and this one has something special going on. Notice that we start with a perfect square, 49x squared, and we end with a perfect square, 4y squared. So if we were to start factoring, chances are we would put 7x times 7x to give us 49x squared, and 2y times 2y to give us 4y squared. Those are the logical choices. So notice that the square root of 49x squared is 7x. Notice that the square root of 4y squared is 2y. Notice what you get when you multiply 7x and 2y. 7x times 2y is 14xy. And notice that the middle term is twice that. So anytime you start with a perfect square, you end with a perfect square, and the middle term is twice the product of the square roots, you have a perfect trinomial square situation. I need to put my signs in here. These would both be plus. And in a perfect square trinomial situation, you end up with the same factor twice. 7x plus 2y, 7x plus 2y. So let's write our answer as 7x plus 2y quantity squared. Now, could we just factor this problem without even realizing we have a perfect square trinomial? Absolutely. So that's sort of an optional thing to think about. If you think about it and it helps you to do the problem more quickly, that's great. If you don't want to think about it and just do the problem as it is, that's fine too. Okay, the next category of factoring that we're going to talk about is called substitution. At least in our book, they call it substitution. I call it quadratics in disguise. So here's an example. 15m to the 4th minus m squared minus 6. Do you notice how that kind of looks like a quadratic expression? If we go back to like problem number 2, that was a quadratic because it was to the 2nd power. That was the highest exponent. Or problem number 3, it was quadratic because, again, 2 was the highest exponent. And the way we factored was we broke it up into 2 binomials. Well, this problem is not a quadratic because the highest exponent is 4 instead of 2. However, it factors like a quadratic would factor in that you can break it down into the product of 2 binomials. So 15m to the 4th could be broken down into 3m squared times 5m squared, and there are other possibilities, but let's try this first. And then we have to figure out how to get negative 6, so maybe negative 3 and 2, or 2 and negative 3, or 6 and 1. Let's stop and think about it. So what if we put a 2 here? That's going to give us 10m squared or negative 10m squared, depending on if we make it plus or minus 2. And suppose we put a 3 here, so for the outside we would have 9m squared or negative 9m squared, depending on whether we put plus or minus. Notice that our goal is to get the insides and outsides to add to negative m squared. So if we have minus here and plus here, then on the inside we have negative 10m squared, and on the outside we have positive 9m squared, and those add to negative m squared. So we have it factored. Okay, now sometimes you'll be able to factor further, so it's a good idea to take a look at the factors you got with a quadratic in disguise and see if either of them factors more. Let's take a look at the next one. And actually, what I think we're going to do is, after we do this one, we're going to stop this video and I'll make a part 2. It's just better if I break it down into smaller chunks. So let's take a look at this one. This is also a quadratic in disguise, and we're going to use substitution. So notice that you have something squared, and then something to the first power, and then a constant. Well, that's just like a quadratic. It just happens to be a little bit more complicated something. So what we're going to do is try to uncomplicate things for ourselves by using a substitution. Let's let u equal 3x plus 1. You don't have to use a u. U is commonly used in calculus and pre-calculus, so I'm just getting you used to it. If you let u equal that quantity in parentheses, then your expression is now 8u squared plus 10u minus 25. And that is a lot easier to factor. So let's go ahead and find the factors of that. Okay, you play around with that one and you find the factors to be 4u minus 5 times 2u plus 5. And remember, you can always check by using the FOIL technique to make sure that it worked out correctly. Now, this is not the final answer. We don't want to leave u in our answer. We need to substitute the 3x plus 1 back in. So we have 4 times 3x plus 1 minus 5 times 2 times 3x plus 1 plus 5. And we're not going to leave it like that. We are going to distribute the 4 in the first one and distribute the 2 in the second one. So when you distribute the 4, you have 12x plus 4 minus 5. And when you distribute the 2, you have 6x plus 2 plus 5. So then to simplify the first factor, we have 12x minus 1. And to simplify the second factor, we have 6x plus 7. Okay, let's go ahead and pause this one, and then we'll pick it up for the remainder of the lesson in video number 2.